Welcome everyone. Hopefully you are in the right place. My talk is called Why You Should Be Language Agnostic, and my name is Niaja Farve. So I feel like anytime you give a talk, you're either in one or two camps. Okay, this guy's scared. You know exactly what you want to talk about, or you kind of have like a vague idea of what you want to talk about. And so when trying to think of a topic for this conference, one of the things that came to mind was how opinionated developers can be. We have these very animated arguments about very arbitrary things like tabs or spaces or like where you actually write your code and all of those kinds of things. And language is also one of them. People get very attached to a language and they don't want to move on to a different language, and at the cost of having some new opportunities. So hopefully by the end of this talk, you'll kind of have the desire to try something new or try a new language out, and hopefully it makes you a better programmer. So I hope some of your takeaways from this talk will be to chase the problem and not the tool, and how you should always kind of be building your skills as a programmer and not necessarily a language expert. And that getting up to speed quickly in a new language is actually pretty fast. It's a lot easier than getting up to speed with a new code base. So to highlight this point a little bit more, I'm going to talk a little bit about my background. So probably like a lot of you trying to figure out what you wanted to do when you were younger, you focused on your interests, right? And so I was taking a physics class, and the professor said that if you like math and science, you should probably be an engineer. So I was like, oh, okay, guess I should be an engineer. And then you look into engineering, there's like all these different types of engineering. There's so many different options. So I loved music at the time, tried to start a record label, but didn't like to talk to people. So I just did all the business side of things and never actually signed any people to my record label. So I thought, okay, I'll be an audio engineer. Had no idea what audio engineers do, but I was like, that seems like the marrying of two things that I really love. My mom was like, oh yeah, let's make that more general. How about electrical engineering? So I was like, all right, fine, cool. So went ahead and did that for undergrad, did electrical engineering as my bachelor's. And in that engineering, in the course of doing that, we had to do an intro to programming class, and the language that we had to learn was C++. So this was my first real exposure to programming, and I really, really enjoyed the process. So after getting my bachelor's, it was time to go on to grad school. I knew I wanted to get a master's, and so I ended up applying and getting into MIT. And so I had a fellowship, so that meant that I got to shop around for what labs I really wanted to be a part of. And so I ended up with a professor that was helping out the biomechatronics lab, which is in the mechanical engineering department. So you might have seen this robot before, but that lab was basically trying to create the fastest quadruped robot, and they were designing it after a cheetah. So they were trying to make it very cheetah-like. And so one of their biggest issues, of course, with anything that has to be fast, is that it needs to be lightweight. And they were doing their design off of motors. If you know Boston Dynamics, they were doing the whole gas-powered approach, and so they had a very heavier robot, where we were trying to be a more lightweight robot. So we had batteries and motors and that such. So my job as my master's project was to redesign the motors such that they gave more power with less weight. So that was my master's project. I had no idea anything about robots. I had no idea anything about motors, but the project sounded cool, and they had like this cheetah robot. So I was like, all right, I'm down, I'll try it, kind of thing. Spent lots of time wiring by hand this motor, and it ended up working. Last time I talked to them, they were still using that motor design for their motors. I'm pretty sure nobody hand wires them at this point, but it was really enjoyable. Although I didn't get to do a lot of programming, probably MATLAB was the furthest extent of the programming experience during that time, but it was a nice introduction. It also told me that I really enjoyed the computer science side of things more than the electrical engineering side of things. So when it was time to stay for a PhD, I decided to go ahead and make the pivot full on. So ended up switching over to the Media Lab at MIT and doing my PhD thesis there. Still in electrical engineering computer science department, but just doing my research in a different lab. So I worked in the fluid interfaces group, and my project, or my thesis, was basically trying to explore how we can use wearables to impact behavior and habits, and how we can have people form healthy habits with wearables. And so this was a great project for me because I'm not somebody that likes to really stick on one thing for so long. So this allowed me to try lots of different projects and different wearables and get to experience a lot of different things and do a lot of different user studies. That was the other great part of it. I wasn't just stuck in the lab trying something and hoping somebody use it at some point. I actually got to have users use it, get their experience, and have fun with it. So one of my favorite projects was using Google Glass, and we did an experiment called Smile Catcher, where users didn't know why they were in the study for the first week. They were just told to wear Google Glass for like a week. And in the second week, we told them that they get points for every time they catch a smile with their Google Glass. And so after the 2 weeks, people came back and said things like they talked to strangers, just hoping to like make them smile, have these like positive interactions with people to try to share these like positive moments. And so it was a really cool experiment. And also too, a lot of people were really down because they got to walk around with Google Glass for like a few weeks. So during that time, I got to try a lot of different languages, Java, Ruby, some web development. And that was also great because I got to get exposure to a lot of different languages. I really enjoyed Ruby, but when it came time to graduate, I was not keen on just jumping right into the workforce, but I also wasn't keen on not making money for an extended period of time. So the MIT had a program where you could sign up to do an internship, and you basically pick the country you wanted to go to. So I picked Japan, and I went to work for IBM Japan for 8 months. In Japan, robots are everywhere, and specifically the Pepper robot that you see here is in a lot of places. And one of the bigger problems that they're trying to solve is the elderly population. So it's very common, used to be very common, that as your parents age, they would come and live with you and you would help take care of them. But now with bigger cities, their children are moving into the big cities, and they're kind of staying in these rural areas by themselves. So what my project was is using Pepper, could we have a robot interact with a human, and having those conversations, could we detect early signs of Alzheimer's? So the robot would have conversations with the person, ask them what you had for dinner last night. When's the last time you talked to your daughter? And using Watson, we'd be able to figure out if that person is starting to have some decline. We also used QUIRKS, and we were able to show Pepper how to do some stretches and have the person do the stretches alongside with the Pepper robot. And we would use Connect to see if they were keeping up with the robot. Another person joined our lab, and he had done his PhD thesis with machine learning, and we were able to program Pepper to play rock, paper, scissors. And so we were able to program it to either always win or always lose. And so it would like see the person's hand, see that you're doing rock, and then do paper or something like that. Or it could always win, or it could just play fairly and just have fun with you. So that was also a really great experience. I did have to go back to C++, which I realized I don't really enjoy. Only because after 2 or 3 days, everything would be running fine, and then all of a sudden there would be a segmentation fault, and I would have no idea where that came from or what caused it, but it would get really frustrating. But overall, it was a great experience again. So then decided to move back to the United States and joined a small startup here locally called Spreedly. And so started to work in the payment industry. And so this was a great experience learning how to write code that can't break, right? Like I had users before, things would break sometimes, and that wasn't life or death or any big deal. Like somebody would be inconvenienced, but that's fine. But once you start talking about people's money and somebody not getting paid, it's a very different situation, right? And so we had to start writing code that I had to make sure I wrote code that would last and didn't break, and was heavily tested. So that was a great experience, and it also got me back to Ruby, and I really enjoyed that. So then when it was time to leave there, you do like most people do, where it's like, oh, I really love this language. I'm ready to go somewhere else. I'm gonna find a company that also uses that language and meets all of my other criteria, and find this happy medium. Well, that's really hard to do, especially when, like me, I like to be remote. I like all these other things. And so finding that company that met all of the criteria was really hard. So I ended up at CNN, which ended up being a great fit for me. Wouldn't have thought of it when they came to me and said if I'm interested. But they were willing to be remote. They were willing to do a lot of other things, but it was JavaScript. And if you are in the Ruby or Elixir space, they like to talk down about JavaScript a lot. So I wasn't keen on like, oh, got to go to this JavaScript world. I also, in my own experience, had several times where I'm writing, some introductory code to JavaScript, and I cannot figure out for the life of me why it's not working. And so you do all the console logs, and you're like, oh yeah, asynchronous, like things are going to happen out of order. And so that bit me so many times that I had like a bad, taste in my mouth from JavaScript. So I wasn't keen on it, but again, it was like a new opportunity. I didn't know media had tech or had tech problems that needed to be solved, but again, it was a really cool, interesting experience to go see what I can do there. So over the last 10 years, it's been a variety of different programming languages, from C++ back to C++, and MATLAB, Ruby, and everything in between. And so my younger self would look at this and say like, oh, you've skipped around a lot and you don't really have any expertise in any one language. Myself today would think about all the things I've learned in those programming languages and all of the hiccups that I had, and understand how I'm applying those hiccups to any new language I learn or any place that I go. That I'm able to apply those shortcomings and kind of get over those hurdles a lot faster than even the people I know that are experts in that specific language. Also with that, I was able to get to a lot of different domains, and I learned how each domain has its own set of problems and how we can solve those problems with whatever language that we need to use it. And because there's such different domains, there's different languages that fit those domains and help you solve those problems easier. So it's not necessarily about the tool that you use, but what is the actual problem. So my first big takeaway is like, I hope that you focus on the problem that needs to be solved and not necessarily the tool. We're probably the only discipline where we really like hone in on this tool and like don't think about what the bigger problem is. If you think of like a carpenter who's like really good at a hammer and he's just like the best at using his hammer, and somebody comes around and says, hey, I just invented the drill. And that guy's like, well, I don't care. I'm really good at this hammer thing. Like, I don't need that drill. Like screws, why do I need that? And then everyone else kind of just moves on past them because they're able to do things faster and better by able to use this new tool and solve better problems than this one guy that just will not let go of his hammer. Not to say that that hammer is not going to get used at different points by different people, but he's also missing out on this bigger opportunity. So let's talk about a fictional example, right? So let's say you've joined this new company, right? They have this new code this programming language that you've never even heard of, but they've tell you that like, yeah, we have this function that adds vegetables to our bins, and we need you to go in and like write a function that removes fruits from the bin, kind of thing, right? I'm gonna like pause for 30 seconds while you try to like piece through how you would attempt the first draft at like writing out what this would look like. All right, so you've probably saw some things that look familiar, right? We have like a while loop here. We have like a whatever that is, and then you're like, oh, that's just while backwards. That's how we end things. All right, we have some like initialization of things. There's some vegetables, there's some fruits, there's some bins. So if somebody told you to take a stab at like taking things out of it, you would probably, copy a lot of the same code. Maybe you would look to see like, what does add vegetable to a bin do? Can I just copy that and rename it to like remove fruit from a bin or something like that? Or maybe there's already a method that exists or something like that. We have some like minus, so that's kind of familiar. There's an asterisk in front of it, but like, all right, whatever. Same with this, while loop. There's an asterisk there, but oh no, it's not that disfamiliar, right? You can piece together what makes sense to you and move forward from there. So that gives us to our next point, that learning a new language is actually a lot faster than learning a new code base. And probably you all experience that when you go to a new company. The overwhelming feeling of just, I don't know what's going on, is not so much the code, but just the ecosystem that you're in. And so getting stuck on that language, actually it takes a lot longer for you to get familiar with your ecosystem or your environment than actually learning this new coding language. So a lot of people are going to come and think or say or have their opinions of like, my language requires expertise. So to those people, I say like, yes, there are languages that require highly specialized developers, and we can all think of those languages. But also too, those are the languages that usually die off the fastest, right? Like they don't have as long as a shelf life as other languages do. They don't last too long. And even when they do, they don't have as many job opportunities. So that's great if you're in an environment that you love your work, you love your job, and everything is amazing. But as soon as you don't like something about your work, your opportunities to go somewhere else become very, very small, right? Also, they usually solve very specific problems. So if you're somebody that likes to be in different domain spaces or solve different problems, you're kind of limiting yourself by this one language. You can't really jump around and get into a different space because this language is very specific to this specific niche of area. And also too, most companies just want good developers, right? They don't really care, well, they should really care about the developers that they're picking and not so much the language. They want the guy that's gonna sit there, or gal that's gonna sit there for 3 hours and stare at their screen like, what the heck is going on? Am I going crazy? And realize that, oh, I'm just missing a comma, and like keep it moving, versus the person that just like, is gonna give up quickly. Also, any company that hires people in general, they know that there's going to be a ramp up period. That's wherever you go. There's going to be time where that person's going to need time to get acclimated to their environment, to get acclimated to everything else. And so they're not expecting you to come out the gate and just be writing amazing code. I know as a developer, sometimes it's like, okay, just give me a ticket, just give me something to do so I can feel like I'm producing something. But you don't always have to have that. Also, having a good developer is better than having an expert in a specific language. I don't know about you guys, but I know there's lots of forums that I'm in that people come and complain about the tech lead at their group that decided to do something horrible, and it makes no sense to them at all, but that's the way they're going because that's the tech lead. Just recently, someone talked to me about how their tech lead is exposing an endpoint so they can do SQL queries and get their results back fast with no kind of security around that at all. And they tried to explain how that's like a really bad idea, but no one else seemed to, they thought it was very convenient that they don't have to go to the terminal anymore to do anything. They can just go to the web browser and type something in. So having a good developer that knows these things is better than just having an expert that can write anything in any language. So hopefully by now you've considered learning a new language. So let's talk about what it takes to learn a new language in 3 parts. So first, when you learn any language, you got to learn the basics, right? So that's assignments, that's loops, that's functions, and most importantly, it's printing, right? You want to be able to get some output really fast to make sure that what you think you're doing is what actually is working, right? Usually that takes about an hour at max, right? You do a quick Google, look at the introduction to a language, you've got the basics that you need to kind of get up and running. Next, you want to really look for and learn the quirks, right? What do people complain about? What is lacking? What doesn't make sense? What makes sense until it doesn't, right? Like we can think of lots of things like in JavaScript it's object-oriented until it's not, and all of a sudden it's functional. Every language has this thing about it that everyone complains about or vents about or whatever. And once you learn those things, when you kind of have those issues and it pops up, you're like, oh yeah, I remember that. That's from this thing or that thing. And it'll just save you a lot of time. Again, that's probably gonna take you like half a day, a little bit of Googling, and you'll probably get yourself under control. Lastly, you really wanna learn the foundation. So this is really what is behind this programming language. What is its origin stories? Who are their founders? And what are the shortcomings it was trying to solve? Like no one just writes a programming language usually just for fun. It's usually they're trying to solve a specific problem that they faced over and over again. So the total time here is a day, but you're not gonna really spend a whole day doing this, right? Like you're probably gonna pick up a book about this language, you're gonna piece through it chapter by chapter, spend a little bit of time every day, really just kind of getting the understanding of this language. Usually for me, like the beginning of the day is like looking at pull requests and just learning more about my ecosystem or my language or something like that. So if you thought about, taking a book, it might take you a whole day to read it if you had nothing else to do, but you're not gonna do that, right? Like a programming book, you're not gonna just chug it in one day. So you might wanna piece it up over several days. And then let's compare that to learning a new code base, right? That usually takes weeks. So where is everything? What is the testing suite? What is the development process? How do I get it working locally? That usually takes like a whole day in itself, downloading everything, making sure it's running properly. And then you start realizing all of this like technical debt that exists, right? So it usually takes you weeks of time to really get familiar with an ecosystem or a code base prior to you feeling like really confident in it and really able to kind of go in and do a lot of changes. Versus if you had like a simple ticket that you just needed to make a simple change to, most developers can go in and make that change without feeling like, okay, I needed to learn all of these other things to make that happen. So the other thing we need to remember is to always exercise your coding muscles, right? So you use it or you lose it. Even when you are at a company for a long time and you're familiar with the language, it gets very easy for you to kind of just get stuck in your routines. You don't get any new challenges, new examples to solve. And so you kind of like lose your oomph, to say. So making sure that you kind of learning these new languages or just trying out new languages is a great way to make sure that you are kind of keeping up to date with your programming. So take a new language out for a test drive. So there's always some new framework that's coming out or some new language that everyone's raving about. Next time you have some idea that you're just curious about, try that new language in solving that problem. If you're thinking about changing career or changing jobs or something like that, you can start doing coding challenges in a new language. So you might do it first in the language that you're familiar with, and then go ahead and try it in this new language. And then take a minute to observe, like, was there less lines of code with this new language? Was this facet easier than that? Really find out what the positive and negatives of this new language are compared to what you're used to programming in. And then find the language that's made for solving your problem. So we shouldn't really ever go into a new problem and think like, okay, I'm just gonna default to this thing. Make sure that you're thinking about the programming language that makes sense for this. So I could think of an example of like applying for a job and it was a web tooling. And so I could do Ruby, but I know there's other languages that make this super fast and super easy. So even though I didn't know them right then, I was like, okay, I'll just try this out for a day. If it's horrible, I'll go back to my default and save some time, kind of thing. Also, it's okay to remember it's going to be uncomfortable or you're going to get frustrated. You're going to flounder, right? Those first few days or minutes of learning a new language is going to be uncomfortable at first. But remember, print statements are your friend, right? Making sure that you're doing exactly what you mean to do. And also your growth is going to be exponential. You're going to start off and it's going to be really rocky. And then as you learn things, you're going to just have that upward trajectory. Things are going to click faster and faster. So don't kind of just jump out right at the beginning because you're just like, what is going on here? Or you feel like they do stuff really stupid compared to what you're used to. Kind of stick through it and just, figure out what is really the issue. Also, make the process easy for yourself, right? Linters are your friends. Most programming languages have some kind of lint feature, which will go through and make sure that your code is written semantically correctly and also make sure that it looks the way it's supposed to look. So every language has its way that it should be written in, kind of thing. So Python, of course, is very opinionated in how it should be written. JavaScript and other Ruby, they all have their ways of making it easy. And a lot of these linters also will show you a better way to do what you're trying to do, right? So you might even know that that existed and they'll tell you like, hey, it's actually better to do X, Y, Z versus whatever. That's also the case because as programmers, we're constantly on Stack Overflow checking something, but that might have been 3 years ago, the answer. And right now the answer is actually something a lot simpler and easier. So using those linters really helps to do that. It enforces those coding conventions and it also hides your green thumb. Somebody coming back to look at your code is not going to be like, oh yeah, what are they doing? This is kind of weird that they're writing it like this. It forces your code to kind of match everyone else's. And so it kind of blends in with everyone's. So if you guys don't already use a linter, I highly suggest that you start to implement it and use it in your day-to-day practice. Also, another thing that programmers are very opinionated about it is TDD, or test-driven development, which is basically writing your test before you actually write your code. So for learning a new language, this can be very, very helpful, right? So you don't spend tons of time trying to figure out if you've written something correctly. You have your tests to kind of prove that it is written correctly. So you can go back and forth. There's no reason that you have to always do TDD all the time, no matter what kind of thing. You could start off writing a method, then write some tests for it, and then you're going to write the next method. So you write those tests for that first before you go back and write it. So it kind of saves you some time. It forces you to code in these like bite-sized chunks or increments so that you're forced to catch those errors early on prior to you kind of writing through a bunch of stuff that you think works and then trying to go back and debug it line by line and you realize, oh, I've made the mistake 50 times now and I have to go back and change it or fix it or whatever. And it forces you to really correct things as you go. And also look at more senior code, but not just anyone's. Just because there's some old code there doesn't mean it's the best code or well written, right? You have to find the right part of the code. Sorry, there's a grammar mistake there. And also find the people that you know that are really good programmers and also really knowledgeable in that language. And most companies have at least 1 or 2 people. I always have that one person I go to and I ask him all of my testing questions because I can never figure out why my tests are not working the way I want it to. So I go and ask them like, what am I doing wrong here, kind of thing. And also too, just to get yourself familiar, pick a piece of code each day to kind of look at and go back to, especially when you're joining a new code base. It's really good to kind of just incrementally go through the code and you'll find a lot of things that you didn't know were there. You'll also be more familiar with where things are. There's so many times where I found some method that I'm like, wow, that's cool that does that. Where is this getting called, kind of thing? And you go back and you find where that's getting called or where it's being used. And then also when you're starting to write your code, you know where those things are, you know where those helpers are, and you can kind of just quickly go in and use them because you're a little bit more familiar with the code base. So a lot of developers, we kind of touch things as we need to versus kind of, getting to know everything at once, but you can kind of do both kind of thing. Also, ask lots of questions. You might be surprised at the answers. There's been several times where I'm asked, like a JavaScript expert, why is this written this way? And their response is, this person didn't know what they were doing. So a lot of times we kind of just copy and paste what was there and not really even realizing or knowing, like, is this the right way to do something? So make sure you ask the questions. And this way you'll also find out where like that technical debt is. And you can kind of go in and change those, or you could find out like there's some new facet of the code that you didn't even realize was there, but since you asked the question, you're kind of more aware of it. And then an expert in a language does not make them a good developer. We've talked about that a little bit before, where just because you know everything about a language does not mean that you are a good actual developer or you know best practices as a developer. So as developers, it's our responsibility to know bad practices, right? So we should be avoiding common security exploits. We should know what those are. Also, every language has their way of they're easily exploited. So making sure that we're avoiding those downfalls. Minimizing technical debt, like we mentioned earlier, once you do see technical debt, at least make sure that it's documented somewhere or logged somewhere, that there's a ticket that exists for that piece of technical debt. And we should be prioritizing good code over speed. So a lot of times we're asked to do a thing and we're asked to do it quickly, and sometimes that's just not possible. So we have to be confident in saying like, yeah, we can do that, but it's not the right way to do it for XYZ reason. I think we should do Y or whatever. And then we also should be leaving things better than when you found it. If you go into a file and you just see it's really badly written or used or something, it doesn't hurt you to kind of go in and change those things. It doesn't mean you have to do it right then and there. If you're doing a simple change, you could commit that change and open a new branch to kind of address the bigger systemic issue that exists if you have the time, or at least log it as some technical debt so that that can be approved later. Also, test the crap out of all the things, right? So we should all aspire to be as confident as this woman here with her holding her money. You're less familiar with how things are gonna break. So it's best to have a lot of tests written such that you can be more confident that you're not breaking something, right? Especially in the beginning stages, don't be afraid to add a lot of different tests for a lot of different situations, because again, you don't know how this is gonna be used exactly. And every code base can use better testing. I haven't yet met a code base where I'm just like, oh wow, they've just exclusively tested everything. This is great. There's always a chance that, or a place that you can add some more code and get some more confidence that what you're writing is gonna be there for the long haul and you're not really causing any more damage or causing issues that you don't see coming. So finally, we're kind of blessed that we're kind of in this circumstance where we get to develop for a lot of different things in a lot of different places. Also, technology is changing very quickly. Technology is kind of pervasive at this point. It used to be, we knew a device that has technology in it, but now it's kind of everywhere. Our cars have it, our robots have it, our vacuum cleaners have it. So we have all of these domains now that we are being invited into that we're not really invited into before. Like those were separate spaces that we didn't have access to. But now as developers, we kind of have the access to kind of go into these spaces. And our best way to do that is to know the language that's gonna best get us the job done in those places that we go into. Again, solving those problems and finding the tools that we really need to make a difference in those domains and those problems. So change is good. I know sometimes it's hard to let go of that like language that we're holding on to because we're just really familiar with it. But being able to change and flex and move on to something else can be a really good experience for us.